Hi, here's a run through of the third practice test for the reactions writing test for honors chemistry. Here we go. On this top section here, we're just going to assume that double replacement reactions happen. You want to check single replacement reactions using the activity series. So here we go. Let's assume the first reaction happens. We got magnesium hydroxide and potassium chlorate, and we're going to double replace them. Magnesium is +2, and chlorate's -1, so ClO3, and there's going to be 2 of those. And then potassium goes with hydroxide. Potassium is +1, hydroxide's -1 when you crisscross them. And then, of course, we'll need to balance it by putting a 2 somewhere, I guess here, 2 KOH, and then right here, oopsies, something like that, 2K. Yeah, that works for me. That's a double replacement reaction. Next one, lithium and oxygen. Lithium, not a sneaky 7. Oxygen is a sneaky 7, so it gets a 2. You're going to combine them. Charge on lithium is +1. The charge on oxygen is -2, so Li2O when you crisscross them. And balance it by putting a 2 here and a 4 there. Next one is the combustion reaction. So we've got C4H9OH plus oxygen. And combustion reactions always make the same 2 things, carbon dioxide and water. And now we're going to balance it. It looks tricky. I'm nervous. Okay, 4 carbons, 4 carbons. 10 oxygens. 5 times 2 is 10 oxygens. And now we're going to run into a problem for this one. Let's see, we've got 8 oxygens here, and then 5 more is 13. I already have 1 oxygen right there, though, so I'm going to leave that alone. It would be dumb to put another number there. Instead, I'm going to put my 12 here. 12 oxygens right here, plus the 1 more where my arrow is right there will give me the 13 that I need. So there's my correctly balanced reaction for this combustion reaction. Number 4 is a double replacement reaction where it's written out for you, so you got to crisscross 4 times. Helpful sometimes to write the charges out so you can see what's going on, and then because you're going to use them a bunch anyway. So iron is +3, sulfate is -2. So let's see, when I crisscross those, chromium 2 bromide will be CrBr2, iron 3 sulfate would be Fe2SO4 3. You're going to crisscross. The chromium goes with sulfate, the iron goes with bromine. So chromium is 2, sulfate's 2, so CrSO4. And then iron and bromine go together. Iron's +3 and bromine's -1, so they cancel, or they don't cancel, that's what you get. And I'm going to put some 2s and some 3s in some places to balance it. I'll put a 2 here. That gives me 6 bromine, so I'll put a 3 here. 3 chromium gives me 3 chromium, 3 sulfates, and I already have 3 sulfates, so I'm good to go. A double replacement reaction. Number 5 is a synthesis reaction where you got rubidium plus bromine. Rubidium is +1, bromine's a -1, so RBBr when you correctly crisscross them, and then you put a 2 here and a 2 there to balance it out. Next one is calcium and nickel phosphate. And I forgot my yellow sheet, so I'm literally walking around my room right now looking for a yellow sheet. Hope it's not too distracting. We're going to check to see if calcium is above nickel on the activity series, and I know that calcium is way up high, and it's well above nickel. So this reaction does take place. I'm going to write it as so. So to do that, we got calcium here. Let's call it an A. Nickel 3 phosphate. Nickel's +3, phosphate's -3, so NiPO4. Reaction does happen. Calcium replaces nickel, so calcium is +2. Phosphate's still -3, so when you crisscross it, you're going to get something like that. And then nickel is all alone. Nickel's not a sneaky 7, so it doesn't need any Roman numerals or anything. Then to balance it, maybe put a 2 here for phosphates, 2 nickels, 3 calciums there. There you go. Single replacement reaction. Number 7 is another combustion reaction. Looks kind of similar to the last one, actually. Too similar. Okay, here we go. C5H11OH combusts in air. Air is oxygen, of course, and it always makes carbon dioxide and water for every combustion reaction. We're going to balance again like the last time. 5 carbons, and then 12 hydrogens. So 6 times 2 is 12. And then oxygens. On this right side, I've got 10 plus 6 is 16. But I already have one here, so I really want to have in the circle 15, because 15 plus the one more would get me 16. So, but I can't have a 7.5 there. That would get me 15, but to fix that problem, what we do is we just double everything. So instead of it saying 7.5, we're going to say 15 here and double all the numbers. So this becomes a 2, our 5 becomes a 10, and our 6 becomes a 12. 10 and 12. And now it's correctly balanced, and it's the lowest whole number ratio. So sometimes you have to double those combustion reactions to get them to balance out. Number 8 is a decomposition reaction. So zinc nitride, you got to crisscross it. Zinc is plus 2. Nitrogen is minus 3. So ZN3N2 then decomposes. Now zinc is alone, but nitrogen is a sneaky 7. So it gets a 2 there. And to balance it, you'll just need a single 3. Okay, so that is kind of a quick run through of the, just write and balance reaction. Number 9 gets us into writing the balanced molecular equations, the total and net ionic equations, and then the reaction we have here is lithium chromate. Lithium is plus 1, chromate's minus 2. So there's lithium chromate, it's aqueous. It's going to react with aluminum nitrate. Aluminum is plus 3, and nitrate is minus 1. So there is your aluminum nitrate. They already crisscrossed them. Lithium goes with nitrate. Lithium is plus 1, nitrate's minus 1, easy. And then aluminum and chromate go together. Aluminum is plus 3, chromate's minus 2, so Al2CrO4, 3. So there is your written and balanced, well, not balanced yet, but there's your written reaction. We could balance it out first by putting a 2 for the lithium. That gives me 2 nitrates. Oh, I already have 3 nitrates here, so we'll get them both to 6. So to do that, actually, I'm gonna erase that 2 and just make it a 6. Now I have 6 nitrates, so 2 times 3 is 2 aluminums. I already have 2 aluminums, 3 chromates, and 3 times 2 lithiums, which would get me 6 again. So there's my balanced reaction now. And then the next step is to find out what the solid is on the right hand or product side. So to do that, you can check the rules. Nitrates never form solids, and so in this problem, I know there's going to be a solid. It says, be sure to label the solid. So this must be, that must be my solid. I can write an S for solid. And an AQ, because this one does not form a solid. You can use the solubility rules to check as well. Okay, next step is to multiply everything out and then write the charges and bring the numbers that are back in front. So to do that, you'd have 3 times 2 lithium, so 6 lithiums, 3 chromates. Chromate is minus 2. You're breaking up all the AQs here. Then I've got 2 aluminums. And what is that? 6 nitrates. 2 times 3 is 6 nitrates. On this side, I've got 6 lithiums and 6 nitrates. And then I don't break this last one up because it's solid. Oops, make that a 4. We'll take it. Keep your solid together. So that's called the total ionic reaction. And then you can see that 2 things repeat on both sides. It's lithium and then the nitrates. Those are called the spectator ions, the ones that repeat on both sides. We don't need them. They don't do anything for this reaction. They are dissolved in water before, and they're dissolved in water after. They're just floating around in there, okay? The interesting part is what makes that solid, and so what makes that solid we call the net ionic reaction. I like to write the metal first. You don't have to, though. So it's 2 aluminums, and then 3 chromates. Oops, that's a minus 2. And they're going to make this solid called aluminum chromate. And keep the solid there. So that's a good example of taking the whole thing from start to finish. We're writing the balanced equation, the total ionic equation, and the net ionic equation, including labeling the solid and also writing or somehow making note of the spectator ions. And then finally in the test, there's just a straight up balance section. You don't probably need to watch me balance all of these. I think most people are balancing pretty well, but might as well do it. So I'll go through and balance. Let's see, calciums, let's get them to 6 by putting a 3 and a 2 there, 2 and a 3. Iron, chloride. Again, a 2 and a 3 situation. So get them both to 6 by putting a 3 there, and a 2 here for the irons, 2 6 hydroxides, and 3 times 2 is 6 hydroxides there. Oh, now they're getting funky. Okay, here we go. Al2O3, might as well put a 2 there, 2 aluminums, 2 nitrogens, 1 carbon. Oh, then I have the 3 oxygens, so that messes things up. 3 oxygens there, and 3 carbons here. I think that's right, but I'm not too bothered to figure out if it is or not. Oh wow, look at this one. N2O. Okay, I'm gonna start there. Let's see what happens. 2 nitrogens, and I have a feeling I want to leave. Okay, 1 sodium, 1 sodium. I want to leave the hydrogens. I only have 2. So I'm going to need this. I'm going to need this. And maybe, just maybe it works. But what if it doesn't? 2 hydrogens, 2 hydrogens, 2 nitrogens. We're just going to assume that it does. I think we're close. You can yell at me tomorrow if we're not. Next one. Potassium and okay, so let's see. 2 potassiums. I have the 3 here, so that tells me I probably want to double this because I've got 5 oxygens on this right-hand side. So let's put a 2 there. That would give me an even number of oxygens. That gives me 4 of the potassium, so 4 there. And then on I need 2 carbons, and then finally add up all the oxygens on the left-hand side. That's 8 plus 4 is 12. I already have 6 right here, so I need to have 6 more. So there's a 3. So there is a balance reaction for that one. P4O6, P4, P2O4. That's fun when they break them apart. Let's see. Common multiple of 4 and 6. 12. So let's get them both to 12 and see if that gets us where we need to be. So I'm going to put a 3 here and a 2 there. That gets my oxygens even. And then on the, let's see, on the left side, I've got 8 phosphoruses. On the right side, I've got 2 plus 4. Oh, no, it doesn't work. What do we do? Shut it down. Start over. Hopefully it works a different way. Let's see. P4, P2, O4. I really liked my 6 and 12 idea, and now I'm kind of stuck. I'll move on to the next one. That way you can come back and you'll be like, why is he still working on it? P4O10 for the last one. Why did I make these so hard? This sounds like a silly problem to have. All right, this last one, let's see, I'm gonna work with phosphorus first. So 4 phosphorus, and then hydrogen next. So I've got 12 here. So I'm gonna put a 6 times 2 is 12 there. And then oxygens on the side, I've got 4 times 4 is 16, and 10 plus 6 more is 16. So there's that one balanced. And then if we return to the last one, sort of the same situation. I'm gonna start with this time though with oxygen, and common multiples of oxygen of 6 and 4 here. I tried 12 and I wasn't having any luck, so I'm gonna move to 24. So I'm gonna put this at a 6 and put this one at a 4, and then so now my oxygens are balanced. Got them both to 24, and then I left the phosphoruses for last. So I've got 4 times 4 is 16 here, plus 6 times 2 is 12, plus the 4 more there is 16. So sort of similar ones to balance there at the end, but they are balanced. So there is a quick run through of types of things you'll see on tomorrow's or whenever. Hey, it doesn't have to be tomorrow. It's whenever you watch this video's test on balancing and writing reactions. This has been really enjoyable and fun, and I hope everyone has a great day. Okay, bye.